Last section that we looked at then obviously was exploring inequalities and what they look like graphically and how their solution set looks. And today, what we're going to look at doing really is stuff that you've already done. We do have one twist with the stuff that you're working with, all right? You okay, Kara?
She's an idiot.
Oh, okay.
What?
All right. Here's the dealio today. We're going to look at basically solving simple equations, but instead of them being equations, they're going to be in inequality form. All right. Guys, go back to the idea of using inverses real quickly as an example. Multiplication and division. If I had an equation like this, 3x is equal to 27, don't tell me what the answer is, but tell me the process for solving this again. Real quickly, what is it going to be, Alana?
Take both sides, divide by 3.
Divide by 3. Divide by 3. We all agree with that, right? Yeah. So what would the solution be here then? X equals 9, right? Okay. Well, today we're going to be doing pretty much exactly the same thing. The only difference is this. You guys are so good and programmed to write equals all the time. When we start working with inequalities, we don't have this sign anymore. What we have are the signs that we talked about. Less than, greater than, less than or equal to, or greater than or equal to work with. And then we want to show what that would look like in a graph. So here's what I want to get at today, guys. We are looking at solving inequalities using multiplication or division. And what we want to be able to do here is ask ourselves, how can you use inverses to solve an inequality involving multiplication or division? All right. Now, there's basically 3 goals that I want to hit. First one being solve inequalities by multiplying or dividing by a what? Positive. Okay. And some people, they mess this up a little bit, so make sure you pay attention to what I'm talking about. Second one, same thing, solving inequalities by multiplying or dividing by a what? Negative number. Now we'll talk about what that looks like here in a second. And then finally, we're going to look at using some inequalities to solve real life problems. All right? So here's what we're looking at. Guys, here's a front-loaded question for you. Kind of read that and look at it. Take a minute, read that. See if you guys might have any kind of way of solving this, all right? So go ahead and read that front-loading question. If you think you might have an idea how to solve that, raise your hand, let me know. This will be something we're not sure of how to do, but if you have an idea, let me know. So go ahead and take a minute and read that. Tyler, you have an idea?
Yeah.
Okay. Okay, B plus 2R. Where did the B come from? You just letting that be blue? Okay. B plus 2R equals 36. I'm going to jot these down up top. You said equals 36, right? Chloe, you have a thought?
I have 2b is greater than or equal to the 36.
2B is greater than or equal to?
Wait, are we doing equations or inequalities?
You just tell me what you think right now.
2b is greater than or equal to 36.
Any other thoughts on how you might set something up like this? Allie, you have an idea?
2r plus b.
I'm assuming R represents red and B represents blue. Any others? Anybody have a solution for this maybe then? All right, we're going to come back to this here. We're going to run through this idea of stuff here. We'll come back to this. I'm going to tell you right now, you guys are off to a great start with that. That's an excellent start up there. A couple of things that I think that we'll discover as we go through this lesson that'll help us fine-tune that up there a little bit. So have those jotted down up top here. We'll come back to this here. Guys, today our core concept is to look at solving inequalities by multiplication and dividing. And the first core concept I want to hit here is talking about solving inequalities by multiplying or dividing by what type of a number here, kids? Positive number. All right. So here's what I want to tell you. Down here it says, dividing or multiplying by a positive will, and I want to stress this, will not change the direction of the sign. Okay, will not change the direction of the sign of an inequality. Okay, Andrew, you got something?
Were we supposed to write those down?
We'll come back to them. If you didn't get them down, it's okay. Yep, so don't worry about that. We'll come back to it. So I want to show you an example real quickly, guys. We talked about yesterday. Remember when we had the 4 people line up here? And who was the one that ordered us yesterday? Kara, when you ordered us, how did you order us the first time? By height. Okay, so we said yesterday inequalities is a great way to make comparisons, right? Okay, guys, we've talked an awful lot about equality properties. I'm going to put something up here for a comparison first. I'm going to compare the number 4 and the number, I better not do that because it's prime. How about the number 4 and the number 16? Okay, first things first. If I had to put an inequality sign in between 4 and 16, what would you put in there? What are you going to put in there? Faith, what do you want to put in there? 16 is greater than 4. So if I read left to right, would you buy it that says 4 is less than 16? Okay. Now, guys, I just put in red. Dividing or multiplying by what type of a number? Positive. Okay, this is a process. It isn't the numbers you start with. It's the process you apply that I'm talking about the positive number with. Okay? So right here, I'm going to make an arrow. Right here, I'm going to prove it to you. I'm going to do a division property of equality on both sides. On both sides, I'm going to divide by what type of a number? Positive. Let's divide each number by positive 2. What is 4 divided by 2 on the left?
2.
What is 16 divided by 2 on the right? 8. Okay, I applied the division property of equality to both sides of the inequality. Property of equality to an inequality. All right, how are 2 and 8 related? How would that sign look? Yeah. Still less than. So a lot of my question was this. In this process, right down here, of dividing by a positive, did the sign switch going from the original inequality to the new inequality? So dividing by a positive or multiplying by a positive will always keep your sign the same. Everybody clear on that? All right, so let's look at an example here. Why don't you guys flip over to the second page.
Sorry, I just want some donuts.
Snack time? Okay. Here's the situation, guys. In this example right here, example 1, you're looking at solving and graphing the following inequalities. Now, we're very good at graphing, all right? The graphing is very simple, again, under the condition that you keep the variable where? Out in the front, okay? So, right here, I have an inequality. It says -4 greater than x divided by what here, gang? Our whole goal this year so far has been to isolate a variable, hasn't it? Okay, so right here, you have x divided by 4, so I would say, what is the inverse of dividing by 4? Multiplying. What are you going to multiply by? What kind of a 4? Positive 4. We've got to get this out of here, don't we? So over here, you're going to multiply this by positive 4. And over here, you're going to multiply this by positive 4. So the process was to multiply by what kind of a value? Positive. If your process involves using positives to rewrite the inequality, will your signs switch or stay the same? It's going to stay the same. So help me with the left side. What have you got here? What's 4 times -4? -16. You just told me since the process was to multiply by a positive, greater than will still stay greater than. What will happen to the 4 in the denominator and the product of 4 with that fraction right there? What are they going to do to each other? Leaving you with x. Have I isolated my variable? Okay, so to graph this puppy, what value do I have to reference? -16. How about the dot? Open or close one? So I don't care which tick mark you choose on the number line. I'm just going to pick right here. What the heck? Open on -16. Hey, listen carefully. Since the sign in the solution right here points right, I should shade right. Right? I'm going to shade that direction. I'm going to say, yep, go that direction. I'm going to say, go the other direction. Ooh, there's a lot of hands up there. Kendra, tell me why I'm going the other direction. Exactly. In our solution, the variable's on the right side. Would you guys buy that this is also equivalent to x less than negative 16? He's mean exactly the same thing. Kendra caught that, you know what, variable's not there. So in order to shade the solution set for this, I would have to go opposite the direction of that inequality sign. Okay? And think about it, guys. Think about it this way. When I shade left for my solution set, wouldn't a value like negative 50 be over here? Is negative 50, when I plug that in, is negative 50 a smaller value than negative 16? Well, I always like to think of temperature, warmer or colder. Would negative 50 be colder than negative 16? I might go outside if it's 16 below, but if it gets to be 50 below,
Well, that's great weather.
Okay. All right. So next example here. Next example. I want you guys to try the next example right here on your own. Okay. Tell me what your solution is, and then maybe what a graph might look like for this. And then when you've talked this over with a partner and you guys agree, give me a show of hands, all right? If you guys disagree, talk about what it is you disagree about. Yeah. Gotta isolate in, right? What? What's your question?
We don't know what to do.
It says 2 times n is greater than negative 14, right?
Sure.
To solve for an inequality, you have to get n alone, don't you?
Yeah.
How do you undo multiplication? So what are you going to divide both sides by? Got it? If that said 2n equals negative 14, what would be both sides to solve for n? You're doing the same exact thing. Got it, Ben? Who's got a solution here for me? Scarlett, what do you think, kiddo?
N is greater than or equal to negative 7.
Oops, I didn't want to make that n that big. All right, how about a process? What was the process? Divide each side by 2. Awesome. Again, guys, your job, isolate the variable, right? Doesn't this say 2 times n?
So,
How are you going to undo multiplication of 2? Divide by 2, all right? Divided by a positive 2 furthermore, so that we don't have to change the sign at all either, do we? So graphing this right here, watch. Watch, watch, watch. Open or closed on my reference value? You're going to be closed. So maybe right here, I'll call negative 7 right there. Shaded in, okay? Then I've got my variable on the left, so what direction am I shading?
right.
Guys, there's one thing I forgot to do with this graph. What is it? Label it. So what value do you want to reference there, Ben? Negative 7. Very good. So if the process is to multiply or divide by a positive number, do you switch to an inequality sign or not? Stays the same, right? Okay, so here's the trickier one. Looking at solving inequalities by multiplying or dividing by. This here, I've got a mistake in here. I want you to change this, okay? Right here, change this word and this word to what? Change those words to what? negative. All right, I forgot to change that in there when I typed that up quickly today. So change that to a negative number. Okay. So we want to look at the effects of what happens when you have to solve an inequality by multiplying or dividing by a negative number. All right. So let's just kind of explore what happens here. I'm going to pick two numbers again. The two numbers this time I'm going to pick are going to be, I don't know, how about 20 and 100. Okay? So if I pick those two numbers of 20 and 100, and I make a comparison between the two, what sign has to go between 20 and 100? Less than is. 20 is less than 100. Okay? Are we okay with that? All right, now listen to what I'm going to do here. This time I might multiply or divide not by a positive, but by a negative. Let's just pretend I'm dividing by a negative number here. Oh, I don't know. Let's divide both sides. Let's keep both sides the same by applying the division property of equality by dividing both sides by negative 10. If I do the same thing to each side, you're not changing a thing, are you? It'd still be balanced. Would you agree? I just picked a random number. I'm showing you what's happening here. Okay? You agree that stuff should stay the same if you divide by the same values on both sides, right, Faith? Okay, let's check this out. Let's see what happens. What do you get over here? All of a sudden, you end up with negative 2 over here, right? What do you get on the right side? Don't you get negative 10? Comparison there. Which value is bigger? Negative 2 is bigger. So guys, in the process of dividing by a negative right here, what happened the way the original comparison was written? Direction of the sign compared to the way it is now. Whoops. It switched, didn't it? Okay, so change will not change to what? Will not change to, how about the word switches up here. So in the process of solving an inequality, if you ever multiply or divide by a negative, what's going to happen to the direction of the sign in the inequality? It's going to switch directions. That only happens when? Multiply or divide by a perfect. Okay, so let's flip over here to the next page. Last one here we're looking at. Guys, in this example right here, we're trying to solve the following inequality, then we want to look at the graphic. It says 3 is greater than x divided by what? Negative 7. So isolating x is still our goal. How are you going to undo that division of negative 7? Multiply by negative 7. Now here's the kicker. Here's the kicker. You say multiply by negative 7 on both sides. So help me out. How about the product of negative 7 and 3 on the left? Negative 21. Be careful now. Since I multiplied by a negative this time, in the process, sign switching or not switching. So greater than shall now become less than. Big idea there. What are the negative 7s going to do to each other on the right side? Well, they'll cancel, won't they? And you're left with x. So there's your solution right there. There's your solution right there. Okay? So I would be open on negative 21, and I would shade to the right. And why to the right? Why to the right? Because x has got to be bigger than negative 21, right? Okay. Show of hands. Process. What are you going to do to both sides here? I want to isolate m. What are you going to do to both sides? Kara, what is it? Shout it out at me. Divide by what value? You're dividing by a what? Negative. So the idea of dividing by a negative right here, gang, idea of dividing by a negative, that's going to do something for our solution. So over here, what are the negative 5's going to do on the left? They're done. You're left with M. Kara suggested divide by negative 5 on both sides. So the direction of my inequality, stay the same or switch? I'm going to switch it because divided by a negative this time, right? So less than or equal to? And then what's the value here, Ben? Careful. Why positive 9? Negative divided by a negative is a positive. Right? What do you guys think? So far, so good? If I was graphing this, what value would you reference? Open or closed? Going left or right? Okay. Now I want to show you something right here because I guarantee you there's going to be an argument here in a little bit. I guarantee there's going to be an argument here in a little bit. I'm going to put a problem up here. Have you got everything that I've at least got up here? Okay, stay with me here. I want to get through this today. Are you ready for this? Why was it? Why what? I'll get there too. Raise your hand when you know the answer to that. I don't care about the graph. Raise your hand when you know the answer, the solution set for the inequality there. I'm not going until I have at least half of your hands up in this classroom.
Come on, my arms are feeling me hard.
Carter, what are you thinking? And it's less than negative 4. Anybody have anything different? Allie, you gonna step out on that little branch there and see what you got?
Like, you divided by positive. So what do you still do the same sign?
Talk to Carter.
It'd be the same sign. You divided by a positive. If you multiplied or divided by a negative number, then you would have had this sign.
Hey guys, the debate's also
So Carter, you want to stick with what you got, or?
I'm going with that.
So what are you saying here, Carter? So what's your final answer? Okay. Why? Let me ask you a question. Let me ask you a question, Carter. And I'm not doing this to pick on you, but why did you switch the sign the first time? Okay. Just because there's a negative number in a problem doesn't necessarily mean you automatically switch the sign. Switching the sign is dependent upon the process that you use to solve it. So, Allie, what did you say here you were going to do?
Divide by or positive.
It's the process, not the start, but it's the process. So I'm going to divide by, since I'm dividing by a positive right here, this will not switch. Okay, so this is correct right here. Okay, make sense to everybody? All right, last problem here quickly, and then I want to run back to that front-loaded question. Okay, how about volunteer to read that example for me here before we finish up today? Allie, will you get that for me, please?
You earn $8.50 per hour at the sub shop. Write and solve the inequality that represents the numbers of hours you need to work to earn.
I should say earn, not here.
Earn $187 to buy a year's supply of sound pencils.
Sounds good to me. All right, so how much am I earning per hour? All right, I'm trying to figure out a certain number of hours right here. So what I'm going to do is I'm going to let H represent the number of hours you need to work, right? Now, guys, keep in mind, what did it say to write this time? Write write and. I have to write an inequality. So I just can't put an equal sign in here anymore, can I? All right, so here's the deal. I need to work. Every hour I work, how much money am I getting paid? If I let H equal the number of hours I work, what would be an expression
For the amount of money you've made at $8.50 an hour over H hours.
What would an expression be for the amount of money I've made at a pay rate of $8.50 per hour over H hours? Yep, 850 times H. Great, Carter. Now, we want that year's supply of Sour Patch Kids, knowing that it costs how much? $187. Do you guys want to work till you get exactly $187?
No.
Maybe. You could, right?
More likely no.
But you could also work, what was the word? You could work extra. So we want this expression to be related to 187. If I want to be able to buy that, do I want this expression to be more than 187? Less than 187? More than or equal to 187? Less than or equal to 187? Greater than or equal to 187. Okay? So how am I going to solve that now, guys? Okay, we've been talking about setting up inequalities where you have to use the inverses for multiplication and division. So when you model a problem with an inequality, you better have some multiplication or division going on, I would hope, right? Otherwise, I've wasted your time. 187 divided by 850. Anybody have a value there? How many? 22. So when you divide by 850, we get H is greater than or equal to 22 hours, which it implies this. You must work 22 or more hours. 22 or more hours. Okay. Does that problem make sense? Yeah. You could say at least 22 hours as well. That's excellent. Thanks, Allie. Yeah.
How would you know, like, that one's got the sign going that way?
Okay.
Oh, and this one's going the other way. How would you remember which way is what?
You remember that chart on page 54 yesterday that I showed you?
Kinda.
That had all the phrases in there about this and that. You might want to refresh yourself with going back and looking at all those phrases on page 54 again. They tell you, those phrases will tell you exactly what sign you would need to put in there, okay?
Yeah.
All right. Hey, guys, I don't expect you to get this down, but I do want to go back to that front-loaded one real quickly, so stay with me for a second, okay? Guys, in all the problems that we just looked at, how many variables were in there? One, okay? I really like what you guys talked about up here, but how many variables do we have in most of these? It'd be really great if I could write it with just one variable. So here's what I'm going to do. I'm going to run through this here quickly. You get it down. Guys, right here it says there are at most 36 red and blue marbles, right, in a bag. So you've got a bag. Some red marbles, some blue marbles. Everybody agree there?
Yes, sir.
Then, it says the number of red marbles is twice the number of what? Blue marbles. It says write and solve an inequality that represents the greatest number of red marbles. Red marbles is denoted by which variable? Okay, R is going to be the number of red marbles. Problem said you have twice as many reds as you do blues. Think differently about that. How many blues do I have compared to a reds then? Half as much. So if 1R represents all the reds, half of R would represent your blues, wouldn't it? So 0.5R is going to be the blues. So it says added together you have at most 36. At the very most there's 36 in here, which means 36 or less. Okay? So I should be able to take 1R plus 0.5R and set that less than or equal to how many, guys? 36. Okay, here's what I'm going to tell you to do. I want you to finish that problem right there to know at most how many red marbles you can have in a bag. Have that done. I also assigned an assignment from 2.3. It looks like some of you may have gotten into that already. That's due for Monday. Okay. So 2.1 is due tomorrow. 2.3 is due on Monday. Okay. Joe, question?
Yeah, I need.
Okay. Let me stop this here.